Penultimate day, here we are. Okay. We are looking for largest model number accepted. Alright. Don't worry, probably enough oxygen left. ALU is a four-dimensional processing unit. Energy variables W, X, Y, Z. Variables all start at 0. ALU supports its instructions. Input, add, multiply, divide. Modulus equal. All these instructions A and B are placeholders. A will always be a variable where the result is stored. While B can either be a variable or a number. Numbers can be positive or negative, but always be integers. ALU has no jump. Okay. Input x, small x, minus 1. Here's an ALU program that takes two input numbers, sets z to 1. If the second number sets z to 0. Yeah, all right. Here's an ALU program which takes non-negative numbers input, converts it into binary, stores the lowest one bit in z, whatever, sure. Once you've built the replacement ALU, you can install in the submarine, which will immediately resume what it was doing, validating submarine's model number. To do this, the ALU will run the model number automatic detection program. Okay. 14-digit numbers consisting only of 1 through 9. Digit 0 cannot appear in a model number. When it checks a hypothetical 14-digit model number, it uses 14 separate input instructions, each expecting a single digit of the model number. Then, after Monad is finished running all the instructions, it will indicate that the model number was valid by leaving a 0 in Z. If the model number was invalid, it will leave some other non-zero value in Z. Additional mysterious restrictions on model numbers, and legend says the last copy of the Monad documentation was eaten by a tanuki. What's a tanuki? Yeah, okay. You need to figure out what Monad does some other way. To enable many submarine features, find the largest valid 14-digit model number that contains no 0 digits. What's the largest model number accepted by Monad? That's great. It's a lot of stuff. I don't know if I want the full... Well, I mean, there's nothing... They didn't really give us anything to go on here. Other than, you know, obviously trying 9 times 14 different combinations, which I guess is what we do, right? We can optimize that by starting at the back. Yeah, I mean, that's about it, I guess. Okay. So that's our program. All right, so each one of these, let's see, we need... all right, so each one of these is going to be parse instruction of the line. And we know that this is input A, add mul div mod equal. Okay. So then, what this returns yet, we'll see. Parse instruction. Let's see. I'm tempted to basically pre-make these with variable references. I guess, because we don't want to reparse it every time. That's a little bit slow. So let's say we get back out is a variable index and a func Adds the value of A and B and then stores the result in A. Now, see, that doesn't really work, does it? This is really just a bunch of actions, if I'm thinking about it. Actions on a state machine. So let's have a state machine. All right. Record state. Long W, long X, long Y, long Z. And then new state 0, 0, 0, 0. That's what's going to be there. All right, so every one of these is going to be an action on a state. Let's see, so instruction is, let's see, instruction is line 0 to 3. We can just switch on this. All right, and then we can say our variables are line 5 split on the space. Well, actually, line 5. Let's do it this way. That's fine. Split on the space. Okay, so input is. Oh, the other thing state's going to need is a list of input. All right, so we'll say public list of int, yeah, or yeah, list is fine. Input values. Get, so we'll just give you one of those by default, so you can add input values into it. So the input return, let's see, state, you're going to do introduce parameter for input. No, I don't know what that is. Oh, whoops. All right. So we add. All right, we have sub state. Add. Oh, there's no. Yeah. Mul. Div mod equal. Div mod equal. Div mod equal. Mod equal default. Throw new not implemented. All right, so for input, what we want to do is we want to grab the variable. All right, so you're going to be variables sub 0. Let's see. Do I really want to do this as, I guess I kind of do want to do this as actions. Let's see, so we say get variable of that. All right, well, let's do that up here because everybody's going to need variable left. Right is variables count length. For the 1, it's null. Otherwise, it's get variable of variables of 1. These are going to be like references. Can I get references that way? I mean, I kind of can't, can I? Can't return refs. So we do it like this. Ref, can I do ref var left? Or can you only do out var? You can probably only do out var, can you? Long left, long right, ref left. It's fine. No, that's not going to work. Wow, this just like suddenly became way more complicated than I wanted it to be. Alright, this is fine then. How about I do it like this? Public long w get set, public long x get set, long y get set, long z get set. Does that make sense? You can start at 0. All right, left is get variables 0, which what we'll do then is this is a property info, get variable, string name. I don't even need to do that, do I? The easiest thing to do on this one would be dictionary of string to property info. Props is a new one of those. You can do it like that. Property info. Alright. And we can say W. These are all lowercase, right? Yeah, so W will be type of state, get property, W. And tell me I can't use that in an initializer, is that the problem? Possible null reference. Yeah, I'm not worried about that. X, Y, and Z. W, X, Y, and Z. So then each one of these is going to return an action back on state. Get variable, get variable. It's going to be props of variables sub 0. Otherwise, it's props of variables sub 1. And what? You don't props. You cannot use a variable props before it's declared. Fine. Okay. So there's the variable. So we'll say input is going to be state input value sub 0. State input values is state input values dot skip 1 to list. What, you're not settable? Whatever. Okay, so that's store. Pull the first input value, right? Add would be let's see, var left value is left get value for the state. You're going to be long. Right value is going to be long right get value of state. Right, maybe null here. Left is not. Unboxing a possibly null value. I don't care. Left value dot set. Sorry, left set value state. Left value plus right value. And I forgot the set up here. That was dumb. All right. Left set value state input. Okay, so we're basically going to do this every time, right? Except slightly different. So multiplication is that. Division is that. Although make sure on the order on division divides A by B, truncate the result. Yeah, that's right. This is all longs, so that's how that will work. This is mod. And then this is left value equal to right value. We store 1, otherwise we 1L, otherwise we store 0L. Okay. So those are our actions. Use of unassigned local variable props. That's fine. You can be up there. So now what we want to do is we basically need to generate all the numbers, right? So yeah, for first in let's see, we have range, right? Start and end. Oh, that's not actually what I was thinking of. It was like not enum. Is it enumerable range? Yeah, enumerable range. That's what I was thinking. Start and count. I don't want to start. We'll just say digits. Fine. 9, 8, 7, 6, 5, 4, 3, 2, 1. Let me do this 14 times. Does that look like 14 times? 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10 and 11 and 12 and 13 and 14. Those are all supposed to be 4 each. And this mixing of .NET and Go in my head is starting to really bug me. All right, so for every one of those digits, we're going to come up with a new state. All right. state input values add n1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That was a pretty good guess. Let's see. State run data. We don't have a run yet. If state z is equal to 0, then we need to return this model number. Except yeah, we're going to add these backwards. Yeah, it's weird, I know. That's not what I wanted. 9, 8, 7, 6, 5, 4, 3, 2, 1. Run the state. If we end up with 0, then we're going to return long parse of n14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Guessed one wrong again. And then here we do throw not implemented. Should never happen. Alright, so now we just need run. So given a set of data, alright, run all these actions on it for each var actions, for each var action and actions. Action. I guess that wasn't really that big a deal. Okay. I guess we'll see what happens here. Given key was not present in the dictionary. 75, that's going to be our... That's interesting. Why did I do that? That's not what I wanted. Alright, let's set a breakpoint here. Let's make sure we're not screwing stuff up. So line 0 to 3 should be INP, right? So where's my immediate window? Line 0 to 3, line 5 plus. Was I one off on that? I was one off on that. Easy enough. W, go. Key 0 is not present in the dictionary. 76. Oh, wait a minute. Oh, so sometimes these are variables and sometimes they're numbers. Yeah, okay, I didn't do that right, did I? All right, so yeah, that's kind of interesting, isn't it? Okay. Let's see. What is the easiest way to do this? Because it might be one or the other. var, let's see, let's just make you a property info, right, and then we'll also do a long for right value already out here, and then we'll say if variables length is 1, alright, and then we'll forget that, and then you need to be null and you need to be 0, I'm sure. If int try parse of variables sub 1 long, and we do out right value, and if that fails, then what we want is right is equal to get variable of variables of 1. Oh no, props. I got rid of that get variable thing, right? Props of variables of 1. Why are you upset? That's why you're upset, right? Okay. Right value, let's see, right null? We'll call you right value. Right value, otherwise you're that. Okay. Now what? Index outside the bounds of the array in 81. Oh. Help if you do the right thing there, buddy. So we don't know how fast this is going, but obviously it's going pretty slow. Console write. Write me a dot, please. How fast are we running? All right, well, let's write every 100. How about that? Yeah, I don't need a breakpoint. Right, this is taking a while. We really have no help as to exactly what the situation is that might cause us Alright, so let's do this. So rather than doing part 1 or part 2, right, we'll comment those out. And we'll say so this sample program, right, so if we say state, and this takes one number, stores the lowest ones bit in Z. Okay, so let's do this for each of our x in enumerable range 0 to 15. Right, we'll have a state, and then we will run the state we'll put in the input values, we'll add our x and run on the data, and then we will console write line w state x, state y, state z, and we'll see if it's actually doing what we think it should be doing. I mean, I guess if we did to 15, we would know for sure, but so it's definitely doing what we think it should be doing. So that's not the problem. There's 14 separate input instructions, each expecting a single digit of the model number in order of most to least significant. So the input model number is blah, it would give you 1, then 3, then 5, so on. This means when operating mode, each input instruction should only ever be given an integer value of at least 1 and at most 9. Sure. Indicate the model number was valid by leaving a 0 in Z. However, if the model number is invalid, it will leave some non-zero value in Z. Model imposes additional mysterious restrictions on model numbers. The legend says the last eaten by a tanuki. That is not helpful. You'll need to figure out what Monad does some other way. Besides trying to reason about this code. Like, I think you're out of your mind if you think I'm going to reason about that code. I don't know, maybe. I mean, they all look like... Problem is, with only 4 registers, you know, we end up with, like, compounding computations going on here, right? And I don't want to run through these by hand. I don't feel the need to console write line these anymore. So I kind of want to just let it run for the moment. I mean, if I'm going to walk through this and actually see what it does, then fine, I'll let it run. Alright, so let's say W, X, Y, and Z. Let me put this over here. Let me put U over here so I can see if you ever give me an answer. And then let's do that like that, and let's do, we need the instructions, right? So let's take the instructions over here. Alright, you can be the whole half the screen again. Stop it, that's not what I wanted. Alright, so you all start at 0, right? We're going to put 9 in there, so that's the input. So that's input. Multiply x by 0. Of course, that's going to stay 0. Add x to z. That's going to stay 0. Modulus x of 26, that's going to stay 0. Divide z by 1, that's going to stay 0. Add x 14 equal xw, that's 0. Equal x 0, that's 1. Multiply y 0, 0. Add y 25, 25. Multiply y and x, that's 25. Add y1, that's 26. Multiply z and y, that's still 0. Multiply y by 0, that's 0 now. Add y and w, that's 9. Add y and 12, so that's 21. Multiply y and x, that's 21. Add z and y, that's 21. So here, at this first stage, alright, at this first stage, this is 9 plus 12. That's it. That's literally all that happens in that first stage. Alright. Where's our data? This is our next set of data. So let's call this digit 1. That's what we'll call it, not W. So here's our next set of data. So now we're going to put another 9 into W. Multiply x by 0. That makes 0. Add x and z, that's still 0. Mod x26, still 0. Div z1, does nothing. Add x15, 15. Equal x and w, definitely not. Now you're back to 0. Equal x and 0, yeah, now you're up to 1. Multiply y and 0, now you're back to 0, obviously. So digit 1 doesn't stay around. Whoops. Digit 1 is now gone. Multiply y and 0, right? So add y and 25, so that's just straight up 25. Multiply y and x, sure, add y1, that's now 26. By the way, that's again, we've seen 26. Z and y, whoops. That goes into z, so yep, you're still 0. Multiply y by 0 will always be 0, of course. Add y and w. This now puts 9 in here, which by the way is digit 2. Add y and 7, so that's 16, so that's digit 2 plus 7. Multiply y and x, that does nothing. Add z and y, that does nothing. So here we are. So far we've invalidated any need for digit 1. Digit 1 is completely gone. So let's see. By the way, we can split these up because of the way my parsing works anyway. Alright, so let's go ahead and do that. It makes it easier to read. It's interesting that it always inputs into W. Okay, so now we're on section 3, right? Digit 1 is irrelevant. That's what we've determined. With 4 registers, it's not too surprising. Let's go ahead and put these on separate lines again. Don't know why I did that. Okay, so input W, so we're putting 9 in there again. Multiply x by 0, that makes a 0. Add x and z, that's a 0. Mod x and 26, a 0. Divide z by 1, that does nothing. Add x12. Equal x and w. Never, that would never be true. Alright, so then equal x and 0, that's 1. We're really seeing this pattern again, aren't we? Y by 0, that invalidates the value of y, so there goes digit 2. And then, sorry, yep, that's right. So there we go, we got 25 again. We got multiply y by x, which gives us 25. We got add y, which is 26. Multiply z by y, so that means z is still 0. Multiply y by 0, now we've got 0. Add y and w, so that's 9, that's digit 3. Add y and 1, so that's 10, so that's digit 3 plus 1. Multiply y and x, sure. Add z and y, sure. Alright, now, we've seen this 3 times. Do I want to say that this is the pattern that's going to be here, and all that matters is the last digit? Let's run the last digit and see if that's what matters. But if that was the case, then we should have already found an answer, right? Because all the 9s plus any digit would have gotten us there. So that obviously can't be the right answer. 2, 3. Let's go to section 4. I mean, these aren't taking that long to walk through, right? All right, so there we go. So there's digit 4. There's digit 4. Multiply x by 0. Mod x by 20. Let's say add x and z. Mod x 26. Divide z1. Add x 11. Equal x and w, right? So that's never going to be true. Equal x and 0. That makes it 1. Multiply y by 0, that obliterates digit 3. Add y and 25. Multiply y and x, add 1 to y. Guess what? It's 26. Multiply z and y. Guess what? Z is still 0. Multiply y by 0. Guess what? Y doesn't matter. Add y and w. So here we go. Digit 4. Add y and 2. So now we have 11. So your digit 4 plus 2, multiply y and x, add z and y. So there you go. There's set 4. So here's digit 5. So now your digit 5, multiply x by 0, add x and z. Mod x 26, div z 26. Add x minus 5, that's interesting, sure. Equal x and w, that will never be true. Equal x and 0, yep, that's a 1. Multiply y by 0, there goes our digit. Alright, add y and 25. And then multiply y and x, we get nothing. Add y1, guess what? It's 26 again. Multiply z and y, z stays 0. Multiply y and 0, y becomes 0 again. Add y and w. So this becomes 9, digit 5. We add 4, which makes 13. That's plus 4, y and x, of course. Add z and y, of course. Oh, wait a minute, add z and y. Add z and y. Have I been missing? Add z and y all these times. Oh my god. I thought those were mols. Oh, holy crap, I have to start all over again. No wonder none of these digits were sticking. Wow. That's bad. Okay, so there's my input. So mul x 0, that's 0. Add x and z, that's 0. Mod x 26, that's 0. Div z1, add x 14. Equal xw, that'll never be true. Equal x 0, yes, that's always going to be true. Multiply y by 0, sure, add y 25. Okay, multiply y and x, that's 25. Add 1 to y, that's 26. Multiply z and y. So that puts 0 into z. Multiply y by 0. Add w into y, so that's digit 1. By the way, this is digit 1. Add y and 12. So that's digit plus 12. So that'd be 21. Multiply y and x, and then add z and y. So this is now 21. Digit 1 plus 12. Okay. Next. This is digit 2 as our input. X goes back to 0. Add x and z. So that goes into x. Mod x and 26, that's the same. Because we're giving it the biggest possible digit, right? So the biggest possible value it could be is 21. Div z by 1 is a no-op. Add x and 15. So this would be 36. So that's 27. Equal x and w. That's never true. That's way too big. Equal x and 0. That's true. Multiply y by 0 gives us a 0. Add 25 to y. Right, and then multiply y by x. Multiply y by x, yeah, that gives us 25 again. Add y1, that gives us 26. Multiply z by y. Right, so then we've got 26 by 21 times 26. All right, so this now is 546. Whoops, this is up here. It's my bad. This is still this. Wait a minute, no. No, that's wrong. Oh god, I shouldn't be using Notepad. I should know better. This is 546. And then this is still 21. Right. That was this. No, this is 26. Sorry, this is where the 26 came from. Alright, I'm like... I just need a text file. Just give me a text file. It's fine. I'm going to do this over here. This will be easier. Okay, so that was multiply zy. Multiply y 0. That gets us, that nulls out y. Add y and w. Okay. Add y and 7. So this is now 16. So this is digit 2 plus 7. Multiply y and x. Nothing. Add z and y. So 540. Did I already have a calculator? I already had a calculator open, didn't I? So 546 plus 16 is 562. All right. So that's all of this plus digit 2 plus 7. Okay. Next. Okay, this is now digit 3. Is this still running? This is still running. I think that's going to run till the heat death of the universe if I let it, but whatever. You never know. It might get an answer. I'm going to throw it over here. You can't see it over there, but I'll at least be able to see if I get an answer. Yeah, I'll be able to see if I get an answer. Okay. So there we go. So this is digit 3 now. All right, so multiply x by 0. Add x and z. So this is now going into x. Mod x by 26. So we already know that this completely gets obliterated by this. And so we know this, the biggest this could be is 16. All right, because no matter what this was, its mod of 26 is 0. So 0 plus the maximum of 16 and then modded by 26, that's 0. Okay, div z by 1 is a no-op, add x12. Equal x and w, that will never be the case. Equal x and 0, that will always be the case. Mul y by 0. A lot of these instructions just feel like they're just nonsense, right? They're just kind of, you know, in the way. Sorry, I'm just trying to make this thing smaller, and then as a result, it just got weirdly large. Okay. Add y and 25. We know how that's going to work. That multiply does nothing. That add gets us 26. We're pretty much always getting ourselves to 26 so far. Multiply z by y. So then this whole thing gets times 26. All right, so 562 times 26 is 14,612. This is like a weird base 26 math system they've got going on here. So multiply y by 0, add y and w, so that's digit 3, and then this becomes 10, so it's digit 3 plus 1. Y and x is a no-op, add z and y, so then this goes in there. Plus that. Actually, you could stay there, obviously. So it's kind of interesting how this is working out. All right, next set of instructions. So here we go. This is digit 4. That gets us 0. That gets us that. And then we mod it by 26. Based on all these multiples of 26, we know this is going to end up 0 again. Divide z by 1 is a no-op. Add x11 equal xw. That makes a 0 equal x0. That makes a 1. Multiply y0 makes a 0. Add y25. What a surprise. Multiply and add. That makes us 26. Multiply z and y. So then all of this gets multiplied by 26. So where's our calculator? That's not the calculator. And by the way, you can go away, notepad. Calculator. So multiply by 26. 379,912. That's what it said, right? Okay. Multiply y by 0. Of course, that puts 0 in y. Add y and w. That puts 9, digit 4. And we add 2 more, which makes 11. We multiply y and x, which does nothing. And then we add y to z. So plus that. I really don't know how much of those parentheses are necessary at the moment, and I hope I'm not screwing them up. Okay, so then what's next? All right, we're on digit 5. Okay, multiply x by 0, of course. We add x and z, which puts this up here. We mod it by 26, and we know that that will... Oh, man. Holy crap, I've been doing it wrong again. My initial input... That... Yes, I thought this would end up 0, but this would end up as digit 4 plus 2. We have to go backwards. Now I'm just sitting over here hoping the heat death of the universe actually comes sooner than I hope. So let's finish off. Great. Up to the top again. I really apologize if you sat through me doing this twice now wrong. Alright. So that's digit 1. We're going with smaller identifiers. Multiply x by 0. That gives us a 0. Add x and z, that gives us a 0. Mod x26, that gets us a 0. Div z1 is a no-op. Add x14. Equal xw, definitely not, never, it's too big, which means it's always 0, which means it's always equal to 1, or 0 is equal to 0. Multiply y by 0 is a 0. We add 25, of course, we multiply those, we add 1, that's 26. Multiply z and y, which is 0. We multiply y by 0, which is 0. Okay, we add y and w. So that's digit 1. I'm not sure that I actually care about the number. I really don't care about the number. Alright. So add y 12. So digit 1 plus 12. Multiply y and x. So that's the same thing. Add z and y. So this goes into z. Okay. That part we probably did correctly last time. So here we go. Now we got digit 2 in W. Well, we want to get x zeroed out. Add x and z. So this goes up into x. We mod x in 26, which should give us the exact same number. Right? Because the largest digit is 9, 9 and 12 is 21, so the remainder of this is always the exact same number. That's what they've been doing wrong. Okay, divide z by 1 is a no-op. Add x and 15, so this is now 27. Equal x and w. Definitely not. Right? Because there's no way single digit could be 27 plus anything. So definitely not. And then yes, we're back to 1. Multiply y by 0, so you're back to 0. Add y in 25. We do the multiply, which is a no-op. We do the add, which gets us 26. We multiply z and y, so we get this. Right? Multiply y and 0, that gets us that. Add y and w, that gets us this. Add y and 7, so that's 7. Multiply y and x is a no-op, because x is 1. And then we add this onto z. So then we have plus this. Okay, that part so far probably looks the same. What's interesting is we have some very common operations here for sure. Alright, we get our 0 and x as always. We throw this up here. Right, we do a mod, which is this now. We divide by 1, that's a no-op. We add 12 into x, so 7 and 12 is 19. Could x ever equal w? No, because 19 is way too big. And yes, it's equal to 0. We might have actually been doing it right incidentally. I don't want to trust that though. Multiply y by 0 means we get 0. Add y by 25. Multiply y by x. Yep, 25. Add 1 to y. Yep, 26, of course. Multiply z and y. So then this whole thing, which by the way didn't have to have that parenthesis, you can now get 26. Right? And then y by 0 gives us 0. Add y and w, which gives us digit 3. And add y to 1, so that's plus 1. Multiply y and x, no-op, add z into y. So we get that. Okay, next set. Still running over here, by the way. I know you can't see it. Digit 4. We get a 0 in x. We get this big thing here. We do a modulus, which actually means we get this. And then divide by 1, add 11, so now that's 12. X and W could never be equal. That's true, which means this is 0. This becomes 0. This becomes 25. The multiplication's a no-op. Add makes this 26. We multiply this by this, which means we do this times 26. I feel like we're going to want this to be the bigger one. All right, y gets 0. Add y and w, you get digit 4. You're going to get digit 4 plus 2. Multiply y and x is a no-op, and then we add this in. Plus that. So the interesting thing is, like, we've seen, here's the 1, and here's the 7, and here's the 12, and here's the 2. This pattern starts to look a little bit different, but I bet we're going to end up with a 4. All right, we're on digit 5. Heat death of the universe still coming. X is 0. X and Z. Big thing. Yep. Mod 26. Yep. That's that. Divide Z by 26. So that's interesting. So what that means is basically this, which can't be any bigger than 11, goes away. And then the rest of this, which was multiplied by 26, disappears. Well, sorry, the parentheses disappeared. We just divide by 26. All right, so add x and minus 5. So this is minus 3. Equal x and w. Now here's an interesting place where we could end up equal, right? This is the first time when we could end up equal. How are we going to branch this for that? If we assume that the pattern is that we want successes here, like this is the first time when like we have a potential rule here, which is like digit 4, is the potential rule going to be digit 4 minus 3 is equal to digit 5? Is that the rule we're looking for? Because what happens if we end up with a 1 here? Let's have two stacks here. Let's say this stack is digit 4 minus 3 is equal to digit 5. Right, and this is going to be digit 4 minus 3 is not equal to digit 5. All right, so you'll be a 0 and you'll be a 1. Okay, which means here you get 0'd and you get 1'd. We multiply y by 0 in both cases. We add 25. So we multiply. All right, so then we multiply. So here we end up with 0, and here we end up with 25. And then we add 1, which means you're 26 and you're 1. And then we multiply z by y. So down here we get the same number. But up here we get times 26. And then we null out, we zero out y. We add y and w. And then we add 4 to y. We multiply y and x, which down here gives us 0, and here is a no-op. And then we add z to y, so then this, whoops, you don't disappear, you just go down there. Alright, so we have that. I wonder how many more of these we're going to end up with. I don't know, I guess we'll find out, huh? Alright, so your digit's 6. I hope not too many, because I really don't know which direction we want to go. Because all these mod 26s, like a mod 26 on this gives you that, and a mod 26 on this gives you that, and neither one of those generally end up being bigger than what we need. So we could, if those things end up collapsing, we could maybe do that. All right, that's fine. All right, so zeros into x and z. Okay, and so a mod 26, which means you're that, and you're that. Divide z by 1's a no-op. Add 14 to x, so that's 18. And that's 15. That will never be true, so that's not one of these weird cases. So what do we see here that deviated, right? First of all, we had a divide by 26, and then we had a negative 5. We don't see a divide by 26 here, we see a divide by 1, and we see a big add to make sure we end up with zeros. Alright, so those are zeros, which means these are 1s. And then these become 0. And then these become 25. Those are no-ops. These become 26. And then z and y means everybody gets 26. All right. Y by 0 means a 0. Add y and w means digit 6 and digit 6. And we add 15. All right, and then we say multiply y and x, which is a no-op, and then we add z to y. So both cases we get that. So here our 15 popped all the way through. Okay, it's time for digit 7. Halfway through, this thing is still running. All right, so put zeros into x. X and z. Put z into x. Divide z in 1 is a no-op. Add 15 to x. Wait, back up. I missed the mod 26. All right, add x to z. Right, so that's that. Add x to z. I missed the mod 26. So that puts us there. And there. Same in both. Divide z by 1, that's a no-op. add 15 more to x, which is 30. Oh, this is supposed to be digit 7, by the way. Still haven't seen digit 7 anywhere, so equal to that, obviously not. It's too big. Which means our x's then both become 1. Our y's become 0. Our y's become 25. X and y is a no-op. Our y's become 26. We multiply z and y, so this whole thing gets times 26. I feel like what's happening here is I'm now realizing that if I knew how to run all these commands and just use the arbitrary digits, then I probably could have done this. But the problem is, like, I'm having to use my brain to know, like, for example, when this split happens. I don't know how I would have coded for that. Add y and w, so now you're digit 7. We add 11. We multiply y by x, which is a no-op, and then we add u onto z. Okay. So that's it for this run. Whoops, that's it for this run. Here's our next set. Okay, you're now digit 8. X gets 0. X gets z, but it immediately gets modded, so what it really gets is this in both cases. And then we divide by 26, which means we pull this number out and that number out. And then we pull that out and that out. So we're going to get another one of these cases. So x and minus 13 is minus 2. What's interesting to me is that... Yeah, alright, never mind. We'll let this play out. Like, but z is shorter in this case. And since we're trying to get z down to 0, like, my guess is that what really matters here is that at the end, we're going to have the case where everybody is an equal digit to get us down to 0. And so what we'll have is we'll have a formula, maybe, that matters, but maybe not. Yeah, actually probably not, because we want 0, right? Probably won't have a formula that matters. What we'll have is a set of rules that says these digits have these relationships to each other. And that will scope our problem space. All right, so we need to duplicate these again. This is really going to suck. I don't know how many of these rules we're going to end up with. I'm gonna make a guess here. I'm gonna make a guess here. I'm gonna save this off and say we're on digit 8, which is the block we're working on is 134. Okay? Because my guess is that we're trying to determine these rules, right? These rules don't actually help us. They don't limit the problem space enough. These rules are going to limit the problem space. So I'm going to go ahead and go with, let's assume we have these rules. All right, so equal to x and w. Let's make the assumption that D7 minus 2 is equal to D8. Right? Because those are the rules that help us. So that gets us a 1, which means that gets us a 0. And then we multiply y by 0, that gets us 0, and then we add 25. Multiply y by x, that gets us 0. And then we get a 1. We multiply z by y, which is nothing, so there's the 26 that we don't want to keep growing. Okay. And then we multiply y by 0. We add y and w, your digit 8. We add y and 5, so you're plus 5. Multiply y and x, you're now 0. And we add z and y, so nothing goes in. Let's save this in another notepad, which is, this is ready to start at 153. So there's another notepad, just in case. So I see a negative 16 here. This is going to be another rule that matters. And a negative 8 is going to be a rule that matters. No negatives here. This is going to be a rule that doesn't matter. Negative 8 does. So essentially what we're seeing is every one of these is peeling data off of here so that z will end up in 0 and giving us a rule that we can then use. All right. I feel like we're making progress. So there's our w, there's a multiply, x and z. But we immediately mod it by 26, which means you're really this, Mr. X. And then we divide z by 26. Divide z by 26. That's going to peel this off, right? And we add negative 16 to this, so this is minus 1. And now we've got a new rule. D6 minus 1 is equal to D9. Okay, so that's a 1, and then that's a 0, and then that's a 0, and then that's a 25, and then it becomes 0 again, which means then it becomes a 1, and which means no multiplication here, and then you get to be 0, and then you get to be digit 9, plus 3, multiply y by x, nothing, because it's a 0. Add z and y, it's a 0, so there we go. So there's our next rule. We got another rule coming up here, too. Okay, so we're on digit 10. 0. We add and then mod, so we know that pattern looks like this. Right? We divide by 26, which means we peel off this layer. And then we add negative 8, so that's negative 7. Okay, and then we say equal, so that means D3 minus 7 is equal to D10. Which means that's a 1, and then is it equal to 0? No, it's not, so you're a 0. Now you're a 0, now you're a 25. And now you're a 0, and now you're a 1, and that's a no-op, and now you're a 0, and then you're digit 10. All right, and then we add 9. We multiply y by x, which means you're a 0, which means you don't come in, and we add z and y, we got nothing. Okay. This is no negatives. This is going to add something to our z. That probably doesn't matter. I'm still running for the heat death of the universe over here. All right, so input W, digit 11, we got that. So you're a 0. You with a mod, you're this. All right, you're that. Divide Z by 1. Add 15, that's 22. Equal X and W, never. Which means you're a 1. So you're a 0, you're a 25, you're a 25, you're a 26, right? And then we multiply z by y, which means you get to be times 26, and then you're a 0, except you're really d11, plus 2. We add, multiply y and x, that stays, and then we add. So then this gets to be that. All right. Okay, digit 12, almost done. So you're a 0. You are an add with a mod, so you're this. And then we divide z by 26, which peels that back out. We add -8, which makes -6, which means this is our new rule. Right, and then that equal is a 1, and then a 0. And then we multiply y by x, which makes a 0. Oh, sorry, multiply y by 0. Add 25, multiply by x, 0. Add 1, multiply z by y, sure, multiply y by 0. Add y and w. Add 3, multiply y and x, 0. Add them together. Okay. Digit 13. So your digit 13. Okay. So x gets a 0. X gets z with a mod, which means you really get this. Which means you really get this. All right, so this whole 26 comes out. We're simplifying a lot. And then add x 0. Yeah, this is entirely possible, right? So d2 plus 7 is equal to d13. 1, 2, 3, 5, 6, 7, 8, 9, 10, 12, 13. We've pretty much got values for everybody. All right, so is it equal to 0? Well, whoops, that should be 1, which means it's equal to 0. It's not, so now it's 0. Y gets 0, y gets 25. Y and x means you get 0, you get 1. You multiply, right? U becomes 0. U become digit 13 plus 3. Multiply becomes 0. And then you don't get added. All right, digit 14. So digit 14. X gets 0. You get this mod 26, which is actually just that. All right. So, and then divide z by 26. You're 0 now, buddy. So if we add x -4, wait a minute, back up. You were 12, right? Yep, so you were 12. Minus 4 is 8. So that is entirely possible. That is going to be our last rule. D1 plus 8 is equal to D14, right? Which makes you a 1. Which makes you a 0, and then you add 25, and then you become 0, and then you become 1, and you multiply, that's still 0, and then you become 0, and then you become D14, and then you become 11. You get multiplied, which is interesting, right? So you stay, and then this becomes the value of z. So then the last rule is D14 plus 11 is equal to 0? How is that possible? I did something wrong there? Let's walk back. Because that rule doesn't make any sense. All right, so D1 plus 8 is equal to D14. That's what we decided was true. What if this is one of those cases where it's just, maybe it isn't true? Yeah, what if we do this? What if we do this? Okay, so if you're correct then x gets a 1, and x gets a 0. So then you get a 0, and you get a 1. Y's get 0s. Y's get 25s. Y and x multiplied, you stay. You're 0. Add 1 to y, so you're 26, and you're 1. Multiply z by y, so you're still 0, and you're still 0. Multiply y by 0, so you're 0. And then we add, let's see, we say add y and w, so y is now d14 and you're now d14, and we add 11. Right, we multiply y and x, which means we get 0. So yeah, okay, this is right. I just did something wrong at the beginning. All right, so these are our rules. All right, so what do we know about D1? D1 is D14 minus 8. Right? What do we know about D2? D2 is D13 minus 7. What do we know about D3? D3 is D10 plus 7. Right? D4 is D5 plus 3. So we already know about 5, so we need 6. D6 is D9 plus 1. We don't know about D7 yet, so D7 is D8 plus 2. So there's D8, we've got D9, we've got D10. What's D11? D11 is D12 plus 6. I don't know if I'm just like inverting this for no good reason. I really don't know. So we've got 11 and 12. What do we know about 13 and 14? Those are already taken care of. So those are our 7 rules. So given any set of digits, all right, you can go over here now. So given any set of digits, you're still running the heat death of the universe, whatever. Nobody cares about this anymore. So for each var n1 in digits, well, we'll call you D1, right? These are our rules. If we're going to do D... So if we know D1, then we should be able to say D14 is, we can do it from this side, right? D14 is D1 plus 8. So I think we have to run off 7 digits. So the digits we want to run, actually, instead of 14 digits. Let's do this side. D14, D13, sorry, D14, D13, D10, D5, D5, D9, D8, and D12. So then the rest of these just become var, right? So if D1 divided by 10 is equal to 0, and D2 divided by 10 is equal to 0, and D3 divided by 10 is equal to 0. This is how I'm making sure I don't overflow, right? Or underflow. I also, well, I have to do 2 checks, never mind. So if D1 is greater than 0 and D1 is less than 10. Alright, we need to do this 7 times. Don't know why it felt like doing it like that. Okay, so we need to make sure that D2, 3, 4, 6, 7, and 11 are all valid. So if all of that is true, so we'll start with 0L, right? As our largest. So if all of that is true, there's supposed to be a parenthesis there. Remove all the unnecessary parentheses. Yeah, please do that. Thank you. Whoa. Why do you suddenly think some of these parentheses are necessary? Whatever. You're bugging me. Alright, so if all of that is true, then this value right, so this is D14, D13. No, wait a minute. This goes in order now. Right? Yeah, this goes in order now. D9, 10, D11, D12, D13, D14. If result is greater than largest, then we'll say console write line found larger result. Alright. Largest is equal to the results. Get rid of all of this stuff and return the largest. Is that, like, could we be that lucky that that's the right answer that fast? Maybe. Okay. As the submarine starts booting up things like the retro encabulator, you realize maybe you don't need all those submarine features after all. What's the smallest model number? Easy peasy. Alright. So you're the smallest, which means you need to start at long max value. And if the result is less than the smallest, we'll say found smaller. And it really only took a lot of time because we were printing things out. And then that should get us smallest. Okay. You can go away. How'd we do on the leaderboard? That's not bad. 314, 257, considering I had to do all that stuff by hand. I wonder if somebody had a better way of sussing it out. Like, I recognized the pattern fairly quickly, but I still think I had to do it in order to make it work. Like, I don't think there was any way for me to have programmed the logic. Like, the logical jump that I needed was for it to run the program and determine the rules, not determine the results. And I don't know that I could have done that backwards. Like, even knowing what it is now, I'm not 100% sure that I know how to do that. All right. So first one on the small board. First one on the big board. Woo! All right. Awesome. Love it. I wonder if anybody else is even trying it yet. I mean, it is Christmas Eve, so it does... I mean, you can see people have been falling off, but yeah, that's the way it goes. All right, well, thanks for hanging out with me on day 24, and, you know, we'll see you tomorrow for the final puzzle.